All right, so question 2, these are the graphs that you're given. It says the region enclosed by the x-axis and the line x equals -2, so vertical line there at -2, and y equals -2x. We're going to spin that. Let me go ahead and graph that first, though. All right, so we've got the x-axis and then vertical line at -2. And then y equals -2x. So that's going to go through the origin and have a slope of -2. So down 2 over 1. All right, and so what we end up with is this triangle here, this triangular shape. And I'm going to erase all the tails around that, because when we go to spin this, like revolve this around an axis of rotation, it's kind of nice if you don't have all that extra stuff in the picture. All right, so this says we're going to revolve this around the line x equals -4. So here is x equals -4. And our ghost shape is going to be on the other side. All right, so first of all, this is going to be washers, not discs. We have a hole in the middle. So it's going to be pi r squared minus r squared. Now dx or dy, it's like we took the y-axis and just scooted it over a little bit. So it's going to be a dy problem. And so immediately we have to go and rearrange this equation. That's not too bad though. You just have to divide over the -2. So it would be y over -2 or -1/2 y, however you want to say that. But you do have to rearrange that equation so it's x equals instead of y equals. So when we go to set this up, we want to use our y-axis for our boundaries. So it'll be from 0 to 4. Let me get out my colored markers here. All right, outer radius, it's going to be right graph minus left graph. So the right graph is this line, so that's the -1/2 y, minus the left graph is the axis of rotation, so that's -4. So it's going to be minus -4, so that'll be +4. And then the inside radius, again, it's right graph minus left graph. The right graph is -2 and the left graph is -4. So it would be -2 minus -4. I'm going to clean that up though. I'll just go ahead and rewrite the whole thing. -2 minus -4. So this would cancel and be +4. -2 plus 4 would be 2. So this is going to be 2 squared. The other thing that people do is that they'll just go, hey, from there to there is 2 units. That blue line that I drew in, they'll just go, oh, well, that's 2 units. So I can see that. But this is where it comes from, right graph minus left graph. All right, so you did have to do this one by hand. You're going to have to multiply this out. Off to the side here, I'm going to write -1/2 y plus 4 2 times. And we're going to distribute all of that to each other. So I'm still writing the integral symbol because I didn't do the antiderivative yet. I'm still doing all this algebra. We have to multiply all this together. So that will be positive 1/4 y squared. And then the outsides are going to give you -2y. The insides are going to give you -2y. So together that is -4y. And then 4 times 4 is 16. All right, and then the second part, minus 2 squared is 4, so -4. I'm going to just erase and fix that. We have 16 minus 4, that would just be 12. All right, and so now we're going to do the antiderivative. So here's the step that's calculus. Now we would want this to be 1/3 y cubed, but there's already a 1/4 there. So that would be a 12th. 1/12 y cubed minus 2y squared plus 12y from 0 to 4. And all you have to do is plug in 4. And I told you you could leave them unsimplified. So you could even just leave it like this. Like just plug in 4 for all of those. And then your lower boundary, if you plug in 0 for all those, you're going to just get 0. So you really don't need to write that. And you can go further in simplifying it, but if you mess it up, it's going to be wrong. So you may as well stop there. All right, so is there another one that you guys want to look at together? All right, so we're going to look at number 6 here. So number 6 says, find the volume of the solid whose base is bounded by the graphs of y equals x plus 1 and y equals x squared minus 1. So this is the one where it's like shapes are popping up out of the paper towards us. What we're going to draw here is just the base of the shape. All right, so x plus 1, that's going to be a line with a slope of 1, and it's going to be also moved up 1. So we're going to start here and go up 1 over 1. And then this is a regular old parabola, just moved down 1. So we'll have 0, -1, 1, 0, and 2, 3. Should be right there. And so this is the base of our shape. Now we have to imagine shapes popping up out of the paper towards us. It says the cross sections are squares perpendicular to the x-axis. So that means it's a dx problem. So I don't need to rearrange these. That's good. Here's our square. The base of it matches up with upper graph minus lower graph. So the upper graph is the line, that's this one, x plus 1, minus the lower graph is the parabola, that's this one. So if you distribute that negative, that'll be minus x squared plus 1, and then the ones combine to give you 2. So this is the base of our shape. And then we're ready to set up our integrals. So we're using our x-axis. It's going to be integral from -1 to 2. So from here to here. And then inside of there, you're going to put the area of your shape. So for a square, it's base times height, but they're both the same thing. So it's going to be this statement squared. And I let you guys just type this one in the calculator. I could have made you multiply it out, but I feel like if there's 3 terms, it just gets a little tedious. And it's like, what am I testing you on here? I want to test you on the calculus. Not like algebra is important, but anyway, I let you type this one in the calculator. So it is going to be integral -1 to 2, and then parentheses x minus x squared plus 2, close parentheses, squared dx. And our answer is 8.1. I didn't put any more decimal points because that decimal stops. Some of you put 0, 0 at the end there. That's awesome. And I'm glad you know about the 3 decimal points because I want them to give you credit. If the decimal stops though, and there's no more to it, then there's no reason to continue though. It is just 8.1. All right, so we're going to look at number 5. So number 5 says, this is a discs or a washers one. We're going to rotate the region bounded by y equals 2x squared, y equals 0, so that'll just be the x-axis, and x equals 2 around some axis of rotation. So let's go ahead and draw that first. Y equals 2x squared, that's a parabola. We'll have 0, 0, 1, 2, and then the symmetric point, and then 2, 8. All right, so there's the parabola, y equals 0, that's just the x-axis, and then x equals 2. So here is the area that we're talking about. Again, I'm going to erase everything outside of that. And this says we are going to revolve around the line y equals -1. So here is y equals -1. And this is our ghost shape down here. So this looks like a funnel when you spin this around. And so it is going to be washers. There is that hole in the middle. So it's going to be pi r squared minus r squared dx or dy. Well, it's like we just took the x-axis and scooched it down a bit. So it's going to be dx. So I do not need to rearrange any of these. And so we're going to use our x-axis for our boundaries. It'll be 0 to 2. Outside radius, upper graph minus lower graph. So that's going to be the parabola 2x squared minus, and then this line is -1. So minus -1, that's going to be +1. And then the inside radius, again, upper graph minus lower graph, it's going to be 0 minus -1, which would just be 1. And the other thing you can do is look at that and go, oh, that's just 1 unit from there to there. So this one we are going to multiply out. And if you want to write 2x squared plus 1 twice off to the side, you can do that. When you distribute all this to each other, it's going to give you 4x to the fourth plus 4x squared plus 1. And then minus 1. 1 squared just gives you 1. So these cancel, which is nice. And now we're going to do the antiderivative. So this would be 4/5 x to the 5th plus 4/3 x to the 3rd from 0 to 2. And again, I told you you didn't need to simplify them down, so you can really just plug 2 into that. And then the lower boundary would just be 0, so that would be your final answer.